So good day everybody. A revision of what we did on so far on concrete slab, and let us look at this example. Let's say we are given a slab of this magnitude, and let's say composite floor consisting of a 150 mm thick concrete slab, and is supported on steel beams spanning 5 meters and spaced at 3 meters centers, is to be designed. Let's say these are the steel beams, and it's carrying this particular slab. As I explained the other time, that when you have a beam like this, that half of the weight will be carried, half of the weight of the slab will carry in this direction, likewise half in this direction. So let's say that the unit mass of the steel beam is this 50 kilogram per meter run. Now let us calculate the design load on this particular internal beam. So the first thing is that, since we know that reinforced concrete, that the normal density of normal concrete is 25 kilonewton per meter cube, and the steel, you are given that the unit mass is 50 kg per meter run, and we all know acceleration due to the gravity, we use our A or G to be 10 meters per second square. Now, if the unit, to calculate the unit weight of the beam is this one times this, that is to say, like mass times acceleration, you know, weight is mg, mass times acceleration due to gravity. So we have 50 times 10, which is 500 newton per meter run. So if you convert it to kilonewton, that's divided by 1000, you have 0.5 kilonewton per meter run. Now let us look at the loading on the slab. The slab is it has permanent load of since the slab is 150 mm, so as given in the question. I think it's the slab is 150 mm thick as given in the question. So definitely our units, the slab weight will be this one times the unit weight of concrete, which is this. We have this for the slab permanent load. Now the imposed load, which is always based on the usage of that particular structure, but for this instance we have it as 3.5 kilonewton per meter square, which is this. Then the ultimate load will be 1.35 times dead load plus 1.5 times QK, which is according to our eurocode design. So this 1.35 times this particular dead load plus 1.5 times this imposed load will give us 10.31. This is for the slab alone. Now for the beam, we have the beam permanent load, which is the self weight of the beam, as we calculated to be 0.5 kilonewton per meter run. Now the ultimate load will be the factor of safety times the permanent load, the dead load. So the factor of safety is this, and the dead load is this. So when you multiply the two together, we have this for the beam itself. Now let us look at the design load. The internal beam, that, as we said, it supports a uniformly distributed load from a 3 meter width of a slab. As I explained the other time, that half of the, when this beam is carrying half to this side, and they are span 3 meters, definitely from here to here will be 3 meters. So that's why we have this particular 3 meter width of slab to be carried. So now the design load on the beam equals to the slab load plus the self weight of the beam. What is the slab load? The slab load is this times this area of the slab, which is 3 by 5 by 3. So we have it as this particular slab load 10.31 times 5 times 3. That's for the slab load itself. Now for the beam, the self weight of the beam is just the self weight times the span of the length of the beam, and as we all know, the length of this beam is 5 meters. So that's why we are multiplying this one by 5 meters here. Now we are multiplying this by 5 meters. So this ultimate load times the length, which is 5 meters. So when we add this and this together, we have 158.1 kilonewton. So that is all on this particular one. So let us go to the next phase. So you can practice the remaining aspect of the calculation. You can practice this. The solution is there. So just practice this example 2.2. and let me see how you are following it, whether you are getting it. So we'll go to the next aspect of this lecture.